Hello everyone, I am Aydin Rzayev.
And I am Ismayil Zeynalov.
So let me share my screen. Yes.
Just a minute for our project codes in Colab.
Can you see?
Yes, I can see you and everyone.
Okay. Uh, we are here to talk about a project we've been working on where we use artificial intelligence to predict air pollution levels. This is a big issue because our air pollution affects our health, the environment, and even our daily lives. So the goal of this project is to create a system that can predict pollution levels in advance, allowing people and cities to take action before the air quality gets too bad. Before we dive into the technical side, let's take a moment to understand why this problem is so important.
And I want to speak about why air pollution matters for us. Air pollution is one of the leading cause of health problems around the world. It can cause asthma, lung disease, and other serious health issues, especially in children. Sorry for that, and the elderly in big cities. Pollution can build up because of traffic, factories, and other source of harmful gases. This makes it essential to have the way to predict when air quality might get bad, so that people can take precautions.
In this project, we focused on predicting one specific pollutant, carbon monoxide. Carbon monoxide is a gas that comes from burning fossil fuels, like those used in cars and factories. It can be dangerous, especially in high concentrations, so predicting its levels is really important for keeping people safe. To predict CO levels, we used AI models that analyze patterns in historical quality data. These models look at different factors such as temperature, humidity, and levels of other pollutants to make a prediction about future CO levels.
When I talked about pollution matters, I didn't speak about examples. For example, on days when pollution is high, people with asthma might need to stay indoors, or cities might put restriction on vehicles to reduce emissions. This is where AI can help us by predicting air pollution levels. We can warn people in advance and help governments take actions to improve air quality. And I want to speak about the data we used in our project. The first step in our project was the collect right data. We used the dataset from UCI machine learning repository, which contains data from air quality monitoring station in Italy. This station measure pollution level in the air as well as other environmental factors like temperature and humidity. The dataset includes the following features. Maybe Aydin can speak about the data set.
The data set. Actually, naming them one by one is not necessary for now, but we can give an examples. For example, date and time, the exact day and time when the data was recorded. So CO, carbon monoxide emission level. This is the main feature we want to predict: the amount of carbon monoxide in the air and other chemicals that is in air. For example, the amount of non-methane hydrocarbons. You see here C6H6, which is the level of benzene, a harmful chemical found in the air, and other. So, in preparing the data, actually we should first look at the structure of the data. We use some functions here. Then, for preparing the data, we used a standard scaler. This step is very important because any errors or missing values in the data can cause problems later on. Here, what we did to prepare the data, First, we looked at the missing values and or null values, and we see that there is nothing about that. So we then dropped the date and time columns because in training steps wouldn't be necessary actually, and it stops the standard scaler to perform its tasks. Then we use standard scaler to scale our data. Then we split our data into training and tests. For building the AI models, Ismail will explain you.
Okay. Once the data was ready, we started building our AI models. We tested the three different types of machine learning models to see which one could predict carbon monoxide levels the best. Linear regression, random forest regression, and gradient boosting regression. First, I want to talk about linear regression. This is a simple model that predicts a value by looking at the straight line relationship between the input data and the output, in our case carbon monoxide levels. It's a good starting point for understanding how the future affect pollution levels. When we go to random forest regression, this is a more advanced model that builds many decision trees and combines their predictions. Each decision tree looks at different part of the data, and by combining them, the model becomes more accurate. Gradient boosting regression. This model also uses decision trees, but it builds them one at a time, each tree trying to fix the mistakes made by the previous one. This helps the model makes better prediction over time. Okay.
So for evaluating the models, we used mean squared error and R squared error. After training the model, we needed to see how well they performed. We used these measurements. Mean squared error is the metric tells us how far of our predictions are from the actual values. The smaller the number, the better the result. And R2 score. This score tells us how well our model explains the variation in carbon monoxide levels. A score of 1 means the model is perfect, while a score of 0 means it's no better than random guessing. Then we use also RMSE measurement techniques. About the results.
About the result, we also visualize the results by plotting the prediction CO levels against the actual values. Aydin will show us these plots. This helped us see where the model made good predictions and where it might need improvements. And application of our project, Aydin will speak about it.
Okay. Now that we have have a working model, let's talk about how it can be used in the real world. For example, in public health, our model can be used to predict air pollution levels in advance, helping people take precautions. For example, if we know that CO levels will be high tomorrow, people with asthma or other breathing problems can stay indoors to avoid exposure. City planning. City planners can use these predictions to make decisions about reducing pollution. For example, on days when pollution is predicted to be high. So policymaking, governments can use the model to create policies for reducing air pollution. For instance, they might set limits on industrial emissions or introduce measures to promote cleaner energy resources.
Okay, I want to speak now challenge and future work of our project. While our model works well, there are still some challenges we need to address. For example, we can improve the model by adding more data, such as traffic patterns or data on industrial activity. We also said that. We can also fine-tune the model by adjusting its parameters to make it even more accurate. In the future, we hope to integrate real-time data so that the model can make live predictions. This would allow people and cities to respond immediately to changing air quality conditions. Item,
Mhm.
please.
Then I want to talk about ethical considerations. Building our AI system like this, it's important to think about the ethical implications. There are got some pros and cons. For example, we need to ensure that the model doesn't favor or disadvantage certain groups of people. For example, if the model is based only on data from wealthy areas, it might not work as well in poor neighborhoods. Um, then there can be some privacy errors. For example, while our dataset doesn't contain personal information, any system that collects data should be careful to protect people's privacy and transparency. Of course, it's important to make sure that people understand how the model works. If the model makes a prediction, we should be able to explain why it made that prediction. And in conclusion, our project successfully developed an AI model that predicts air pollution levels, specifically focusing on carbon monoxide. This tool has the potential to improve the public health, guide city planning, and shape environmental policy. While there are still areas for improvement, we are excited about the potential impact of this technology. Thank you for your time, and we are very happy to answer any questions you might have.
Thank you very much.
Thank you. Thank you.